Hello, I am Yonghyun Kim, and he is my co-worker, Sungwook Jang. In this session, we will explain about our fake stock program scam analysis case. This presentation focused on how we track a fake trading system fraud and what we have discovered. We secure the financial IT lifecycle in South Korea, providing a safe and reliable environment. Due to time constraints, I'll leave it here. If you want more details about our works, please visit our website. Since COVID-19, South Korea has seen a stock market boom. Scammers exploit this trend, using fake stock trading programs to steal money. If you have heard about the pig butchering scam, I believe it's a fitting term for this case. These crimes resemble the ransomware as a service and malware as a service models. A vendor supplies the software, while affiliates use it to execute the crimes. We monitor and respond to various sources, including social media. One day, I came across the tweet from a malware analyst. It revealed that screenshots from impersonated infections were being exposed via directory listings. I reviewed some of the exposed screenshots and found something interesting. I have started analyzing some of the screenshots and noticed something suspicious. In these screenshots, you can see a general manager in title bar and direction message in group chatting and suspicious management user interface. These clues revealed that both victims and criminals' photos were being exposed. In addition, we found the user interface was nearly identical to Torship, a trading scam covered by South Korea public broadcaster. We identified several operational security failures among criminal actors. I'll explain three key examples. The first and most critical mistake is the list of screenshots exposed by the server misconfiguration. Most of the screenshots were from victims, but there were also some from criminals, which were important in the investigation. In the second case, a criminal device was also used for everyday use, exposing it on criminal's identity. We identified a screenshot of an affiliate member playing a specific game. In South Korea, due to game age regulations, identity verification is required to play these games. So I thought these characteristics would be crucial clues to their identity. Additionally, home address and other personal details from criminals' daily lives were exposed through screenshots. Of course, these criminals are aware of this spying feature, but either trust the supplier or believe they have control over the screenshots. Finally, another critical mistake was that the same problem exists during development. Suppliers unintentionally expose sensitive information while developing the software, like server credentials, their communications, and software development environment. We were able to find identifying information about the main developer based on screenshots left by the main developer. We found there a major activity on TradingView, GitHub, and Android app stores. Next, I will explain our tracking approaches. First, we collected existing screenshots from the identified fake trading systems automatically and programmatically. If the collection process was used multi-threading or multiprocessing, it could increase server load, potentially disrupting existing service and alerting the attackers. So to prevent this problem, we collected data from all identified servers, but limited the download speed by using only one thread per server. This approach allows information to be collected with minimal risk of detection caused by server disruptions. And we need to quickly analyze 12 terabytes of collected screenshots, so we filtered out known targets. First, we excluded possible victims who are assigned user numbers above 1,000. Then we used template matching techniques with their favorite tools such as VPN software and code editors. The supplier runs a server for development and demonstration to help affiliates decide whether to make a purchase. We suspected this server held more important screenshots. Finally, we are right. We discovered information about various development environments and infrastructures. We reviewed the information closely and found that services like IIS web server, FileZilla FTP server, and RDP server were assigned to specific ports. We suspected there were more servers we had not found yet, so we used two methods to identify those attackers' fake trading system servers. So we identify suspicious servers through the fault assignment patterns and continuously detecting new servers via passive DNS histories. And we also recorded IP address change, such as web page updates and more for identified domains. This enabled efficient tracking of affiliate changes, missing Cloudflare CDN protection, and other key activities. We found the three signatures to use to sign the installer, which helped us spot potential facilitators and future installers. Supplier used a privacy protection service for domain registration, but sometimes missed it. So we discovered that the company issuing the code signing certificate was also used to register the domain. Finally, we were able to uncover the entire fraud process. This is the overall campaign flow looks like this. While it may seem complex, but it's not complex. It's similar to ransomware as a service model I previously mentioned. Basically, supplier and affiliate are Korean-based criminals, and their targets are Koreans. So for this reason, supplier located their servers in data centers in South Korea and Japan for low latency. And they also use APIs from Korean securities firms to patch market price, integrating them as our data for their trading systems. And supplier writes their advertising post by editing old ones. This trick to avoid censorship by website administrators and potential affiliates can find this post through search engines like Google. In addition, they create a website for advertisement. Affiliate face a fee to supplier from subscribe fake trading system. Considering the high cost of food expenses, it's evident that a single affiliate can involve a large number of criminals. Basically, affiliates do phone call using phone number lists to advertise their fake trading system. In this screenshot, you can see a phone number list and Android remote control application. This is an example of luring using YouTube. Some affiliates buy a popular YouTube account and repurpose them for advertising. They utilize the existing subscriber base to effectively advertise their trading system. They lure victims into chat rooms through the mentioned method. Using multiple messenger program instances, they prompt victims to invest in the fake trading system. It has two purposes. The first is to drive deals in the wrong direction. The second is build trust in the affiliates through a one-man showing. If victim shows suspicion, they stage a one-man show to blame the victim, ensuring they stay compliant. They trick victims into losing money through misleading trades. They also suspend users and extort money for reasons that don't make sense. Have you ever seen a financial company suspend your membership and take your money because you just use this code? No. Not surprisingly, the money is never returned to victim. Affiliates use a remote desktop instance to manage money rather than their own computers. This helps them hide their real IP address and allows them to scam safely. Next, my co-worker Jang Sung-wook will explain the result of his analysis of fake HTS programs.
From the early stage of collecting threat intelligence, I conducted program analysis and observed the evolving change over an extended period. I tracked modifications such as code signing certificate change, the application of obfuscation techniques, PDB change, and the alternation of hard-coding server address within the program. Additionally, the screenshot I collected revealed backend processes that could not be identified solely through program reverse engineering. One of the images shown an individual, presumably a developer configuring database-related setting. The developer in this image is using the REST API to test and improve the system. Specifically, it appears they are using the API to request configuration values from the server, which are needed for the client program to function correctly. This process allows for dynamic interaction between the client and server, ensuring that the right settings are applied and enabling the system to adapt to changing requirements. PDB is a symbolic element that can provide insight into the development environment of a compiled and deployed program. Over time, I observed change in the PDB, which suggests that developers may be working in different environments or that multiple developers are involved. The operation we tracked was named Operation MIDAS. This naming was inspired by the PDB and based on the presence of obfuscator string in the fileface. It appears that the developers are intent on applying code obfuscation. In fact, code obfuscation was applied in version 1074. This fake program references an XML file located in a specific path during execution. Inside the XML file, there is a unique code for HTTPS, and the program attempts to connect to a server by mapping this string to corresponding server addresses. Through the analysis of this part, it became clear that this program is being distributed under different names. Similar patterns were also found in the collected screenshots. The function names in the decompiled program matches those seen in the developer screen in the screenshots. Based on this, it was strongly inferred that the person in the screenshot was likely the developer of this program. So, are the users aware that the program is collecting screenshots? No, they are not. This program does not notify users anywhere that their screen is being captured. The chart was developed using the TradingView API, and the UI is designed to look convincing. Users are left with no choice but to think of it as an investment program. But is their investment safe? No, we cannot be sure that it's safe. The operators use a separately developed admin program to monitor users. Based on the highlighted parades at the top, it seems they do not want to be caught monitoring users. After observing user screens, they add those who have made high profit to blacklist using various excuses. Once added to the blacklist, users are blocked from accessing the program without being able to recover the funds they deposit for investment. This confirms the malicious intent of the operation, aimed at preventing users from getting their investment back. They monitor users' account balances in real time. As a result, they focus on users whose account balances are steadily increasing and who have high investment returns. They examine the user's investment screens to find justification for blocking them. They also check the process list, and if a remote program is running, they assume that someone else is remotely controlling the investment, leading to a block. This is not the only reason they block users. There are various other justifications for doing so. Such a powerful admin program is not accessible to just anyone. A key must be registered on the operation server to gain access. The key is generated by combining the CPU ID, motherboard serial, and MAC address string, then encrypting it use AES 256. The resulting string is recorded in the registry. The admin program is equipped with anti-debugging measures to hinder reverse engineering analysis. Why manage the admin program so secretly? It seems they didn't want their monitoring activities to be discovered. Once they make a significant profit, they change the access address by modifying hard-coding values in the program. As a result, when users attempt to connect, they are met with an error message and access is denied. They are also unable to recover the money they deposit for investment. After some time, they create a new STS under a different name and repeat the fraudulent activities. So let me explain how we responded. During these processes, we identified a total of 125 fraudulent HTS programs of the same kind. We also created Yara and Snot rules. And we provide security monitoring for the domestic financial sector and operated an information sharing system. The detected threats were shared with financial companies to help prevent fraud among their employees and protect against corporate data leaks. Additionally, we took steps to prevent indirect financial losses by coordinating with national agencies to block a domain impersonating financial institute. The law enforcement agencies worked with us to apprehend the members of the organization. The numerous servers, laptops, and other equipment shown on the right were seized by the authorities. As a result, 32 members of the organization were arrested and all were charged. Among them were developers. We hope that crimes such as stealing money from innocent citizens will be eradicated. Through these processes, the LNL we've gained are as follows. First, there are still many undiscovered cybercrime clusters. Second, contextual literacy and continuous tracking in the process of evaluating. External threat intelligence are crucial. We can identify the timing of when attackers make mistakes and properly confirm those mistakes. Third, criminals are also using Gen AI extensively. This means the cycle of cybercrime is accelerating, and we need to think about how to respond. So you can access the detailed report of this campaign via the QR code. I will be available to attend the event even after this session, so feel free to ask any question at any time. And if you have any questions,
Oh, yeah.
thank you.
Just very simply, do you know why they were taking so many screenshots of themselves and why they were uploading them somewhere? That sounds not very smart.
Sorry, one more, please.
No worries. Do you know why they took screenshots of their own computers, their own systems, and why they uploaded the screenshots?
Maybe monitoring users and block steadily increase profit and to block users, maybe. Thank you for listening my presentation. Have a good day.